Test, test. Hello. Okay. I think we won't get too many more people here in the audience, so you can actually move a bit closer.
Okay, nobody wants?
Okay,
No.
it's after lunch, I know.
Okay. Yeah. Okay. My name's Andreas Bog. I'm together on stage today with Ralf Benrath, and we're going to have a look at deep packet inspection. I'm going to do the technical aspect, and Ralf is more looking into the political aspect, question of net neutrality in legislation, etc., etc. So I'm going to start here. What is deep packet inspection, and why do you need it, or why do you maybe don't want to have it? That's how many people perceive the internet. You know, you see you have your new iPad and your wireless router, and that's connected to the internet. And then the internet on the other end is connected to a computer which serves your web pages or where your World of Warcraft is running or whatever. Reality is a little more complex than that. It's more like this. It's an actual visualization of what the internet looks like, and because that's a bit too complicated, I'm going to explain it on a little model. So that's a model of how the internet works. We have, I'm taking one. Test 1, 2. Okay. You have here again the router, the wireless router, which we've seen. And then you probably have a DSL line connected to a DSLAM, which is close to you. And that's got a line to a router near you. And that router got a connection to a router somewhere else, like in London or in Frankfurt. And from there, another line goes to another router. And that eventually is connected to the machine on the other side. So that's roughly how the internet works. I'm going to have a closer look at protocols. What's important to remember in this view is that I have an end-to-end connection, right? I'm starting here, and I'm ending there. And there must be ways to transport my data. So there must be a way to transport bits across my DSL line. And there must be a way to talk to the device on the other end of the DSL line. And then there must be a way to tell the router on the other end of my line where to send the packet so it ends up at the right server. And in the end, what I have is sending packets from here over all the connections to there, and from there back here. And I have a layer which completely abstracts that this happens. So I open a connection and I get back a working connection, and then speak like HTTP on top of that, or World of Warcraft protocol, or voice over IP, or TV, or whatever. So the usual model that you get taught in school how all this works is the OSI reference model with 7 layers. It starts out with the physical layer, and then the data layer, and the transport layer, etc., etc., etc. That's a little bit more complex than what actually happens out there with TCP/IP, because TCP/IP was a bunch of drunk students at the university inventing it. Well, almost. And the other is a committee standard, and committee standards don't work. So we've basically 4 layers in the real world internet. The first one is the network access layer. That's if you have Ethernet, it encodes how zeros and ones are transmitted, how I send packets. Then the next one on top of that is the IP layer, which is I can send packets. Then on top of that is the transport layer, the third layer. And that takes multiple packets and assembles them into a stream if I want to, which is TCP, or it doesn't in case of UDP. So basically the transport layer is providing me the end-to-end connection. And on top of that is the application layer. That's the application I'm running, HTTP, World of Warcraft, whatever. So again, those 4 layers translated in names that might be more familiar to you. We have down here, that's Ethernet, FDDI, ATM, we have DSL, everything, wireless network, which often doesn't work. And on top of that, we have IP packets. So if you remember that the picture I shown with all the nodes and connections in between, this layer roughly handles how the nodes communicate. The layer on top of that, the IP layer, handles sending packets from one end of the network all the way to the other end of the network. Then on top of that, I have the transport layer, which gives me a stream connection out of the packets, and then useful stuff on top of that. So that's roughly how the internet works. So again, another view on the same topic is the actual bytes that get sent out. So if you see a network packet on the wire, like your DSL line or your Ethernet line, it consists of a frame header, which basically addresses the other end of the line. Then inside of that is an IP packet, which says what's my end destination I want to reach through the network. Then inside that is a TCP or UDP or whatever header, which says that's a 20-second packet I'm transporting in the stream, and if I'm getting the 24th before the 22nd packet, I need to reorder it, etc., etc. And then in the end, you have the actual application data. Okay, I think you can form a picture of how routing in the internet actually works from that. That's, this is my computer again. That's the computer on the other side. I open a web page. So it says, oh, I need HTTP. I make an HTTP request. And HTTP says, I need to open a TCP connection. And the TCP connection consists of IP packets. And that IP packets get sent out on my DSL line. So now it goes to my DSLAM, so the DSL termination point. And there it's decoded. It looks at the IP packet, looks at the destination address of the IP packet, and out it goes again on the next line. And only the other node at the end actually cares about the transport layer and the application layer again, reassembling my packets into a TCP stream, and parsing the GET request, finding out I want to see porn, and sending me the porn. Okay, so that's the nitty-gritty details of what's inside a TCP/IP packet. It's an IP header up here. It's a TCP header, and eventually data that's transported for the application. So in ordinary routing, all the intermediate nodes we've seen only look at this, the IP destination address. So I send a packet, it looks at the destination address and knows whether to send that to the left or to the right side and forwards the packet. End of story. But now the packet inspection comes in. What does that mean? That means that not only reducing the 7 OSI layers down to 4, it also means completely forgetting about all that abstraction bullshit and actually looking at all the other data in the packet again for making routing decisions. And the stuff we can look at is, for instance, the type of service or the TCP destination port. You see, if I want to talk to TCP port 80, it's probably going to be HTTP. If it's something else, then maybe I don't want to forward the traffic the same way that I do in this case. And the packet inspection goes as far as not only looking at all the headers, it goes as far as looking at the actual data I'm transmitting. So that means that I could do stuff like routing the HTTP requests on the left line and routing other requests on the right line, or giving priority to certain traffic. So that's what people are actually doing. That's what they're using DPI for establishing quality of service parameters, like giving priority to voice over IP, so that the voice conversations will keep on working. Question is, how efficient is this? Back in the days, we only looked at the destination IP address. That's 4 bytes. And that was pretty fast to find out where to send the next packet to. But now imagine we have a complex set of rules which say if there's UDP traffic with voice over IP, give it a higher priority. If it's a torrent download, give it a lower priority. And if it contains evil packets containing a denial of service attack, drop them completely. So it sounds in the first place like it would be very difficult to build a router that actually looks at all your details, at all the bytes in your packet, right down into the application layer protocol. But it turns out that it's pretty easy to do. And that's where all the deep packet inspection stuff is coming from virus scanners. There is an algorithm called Aho-Korasik algorithm that compiles many, many different strings you search for into one big state machine. I don't know how many people have heard about state machines. It's basically a construct that says I have a state, like my state is 3. Then I look at the next byte coming in. I have a table which says if I am in state 3 and the next byte coming in is 5, my next state is 8. And finally it says next state is 0 and please drop the packet. And it's completely possible to compile all your rules you have, doesn't matter how many there are, into such a state machine. And it's very, very efficient to execute such a state machine. It's essentially one access into a table per byte coming in. So it has been possible for quite some time now. I think the oldest implementations date back 10 years or more to do that in wire speed. As far as the internet gets, it's possible to do deep packet inspection onto it. The whole research has been coming from the security side because as I said, virus engines have been using that algorithm forever, and people have started researching into intrusion detection systems, detecting patterns of attacks on your network wire, and that's where the deep packet inspection is originally coming from. And at some time, people realized that if I can distinguish between different types of traffic, I can do quality of service on that traffic and give priority to a certain type of traffic. So the application of deep packet inspection to traffic engineering is a newer one and maybe 5 or 6 years old now. As I said, it runs in wire speed if you use an FPGA or a hardwired chip. I've looked up some of the devices. Essentially, every big manufacturer these days has such a device. That's a Cisco Service Control Engine. Does multiple gigabytes per second and controls Cisco routers, so it's an extension to routers. Other people, like Force10, they have that as a built-in card for their routers. So that's a 10 gigabit Ethernet interface card that already comes with built-in deep packet inspection capabilities. And finally, that's the fastest I could find. It's a Sandvine deep packet inspection engine. It does 60 gigabit per second. And if you cluster it, it does 360 gigabit per second. And that means, at the end, that as a telecommunications provider, you have these days the technological means to right on your backbone, distinguish between different types of traffic and treat them differently. Which, of course, has deep political implications, and I think we had quite some discussions about net neutrality today already. And with that, I'm passing over to Ralph, and maybe we can back in conclusion to a discussion.
Okay, so I'm not a technician, I'm a political scientist, but I think I understand the technology a bit. What I'm talking about now is based on a research project I've been involved in at the University of Technology in Delft in the Netherlands until last August. Since then I've moved somewhere else. I'm actually now working in the European Parliament, but this is related to my previous job, so to speak. So I think Andreas has hopefully for everybody made pretty clear that there's something big going on here. Wie mache ich denn hier vorwärts? Ah, okay. And I found this very nice quote from Larry Lessig from 1999 already, more than 10 years ago, in Code and Other Laws of Cyberspace, where he said, the good old internet is basically like a daydreaming postal worker who just sorts your letters, looks at the envelope and the address, sends it there or there, and doesn't care about the content. And Lessig also said this minimalism in design is intentional because it reflects both a political decision about disabling control and a technological decision about optimal network design. And then in later writings he also said this is actually also good in an economic way in his later writings on free culture and so on. And these assumptions are actually challenged now by this new technology. It basically is a technology of control, you could say. It changes the network design, it enables political control, and it also promises new business models. So altogether, I call it a disruptive technology, or at least a potentially disruptive, potentially because it really depends on the context it works in. So political control, what it basically does is integrating a couple of other technologies that have been there before. For law exception, lawful interception, for example, or other things, if you wanted to analyze internet traffic, you needed to log it, write it into a file, and then analyze it later. Now with DPI, it's possible to analyze it in real time. For filtering and censorship purposes, normally and still today, they are mostly based on DNS manipulation or IP filters. Now with DPI, you can actually look into the content and filter out content, dangerous words, whatever, no matter where they come from which IP address they come from, and so on. And of course, the copyright industry, the content industry is also pretty interested in this. They have tried to control their intellectual property by digital restriction management technologies, by watermarking files and stuff like that. And now they are, at least some of them are also pushing for deep packet inspection to basically force the ISPs to filter out MP3s or stuff like that. But then there's also a couple of people nowadays who think this is actually better network design if you use DPI. It's better for bandwidth management. You know, in the old times when the pipe was congested, you know, when the tubes were full, TCP has a built-in congestion mechanism, but that basically treats every packet equally. So as Andreas said, if you want to have low latency for voice over IP, you can't really do that. You can try to do it with quality of service protocols, but they're not really working because basically every application can say, I want to have higher priority, and then of course you end up in the same situation. Now with DPI you can do application-based routing, so you can really say, this application needs more speed, this application is not so time demanding, so you distinguish between it. The drivers for that, of course, are last mile oversubscription, and at least some people say peer-to-peer traffic, and a lot of traffic that, also video traffic nowadays, that clogs the tubes. Then some ISPs use it for subscriber management, mostly as far as I know in the mobile internet business, where you have pay by minute or pay by volume. And now with DPI you can actually say you don't just pay per gigabyte you use on your phone or per minute or whatever. You can even say, okay, with my mobile internet pack for 30 euros a month you get these and these and these websites or services or whatever for free, and for the others you have to pay extra, or you only have, I don't know, 1 gigabyte per month or something like that. And that, of course, may actually be a good idea if I compare my internet use with that of my parents. Actually, my parents don't have internet yet. But that generation, there's different demands and different ways of using it. And if people just want to click at some websites every once in a while and send some emails and don't want to do heavy file sharing or other things, why shouldn't they say, okay, I pay much less to my ISP and in exchange I can't use BitTorrent, which I wouldn't use anyway. Yeah, and then as Andy has said, network security, of course, is a big driver, has been a big driver for DPI. I think I don't have to go into that in detail. And then also, it enables new business models. It enables vertical integration. That means my internet provider can also now offer video on demand or other things. In the old times, in a way, it was used. It was done by tying. So if you had only one internet provider in your local neighborhood, for example, which is the case in a couple of areas in the United States till today, they could basically say you have to get my connection, and you also have to buy, I don't know, video on demand if you want to have that. Or you have to buy a phone line if you want to have internet. Now they can just say, okay, I don't care, I give you internet connectivity and I just offer you to also buy video on demand on top of that. You don't have to buy it, but they can throttle down competing video on demand services. Yeah, the same for telecommunication services. I think T-Mobile is still blocking Skype on the iPhone, is that correct? Yeah. At least in the Netherlands, okay. And that's, of course, in their perspective, understandable, because if people can use Skype on their iPhone, they don't use telephone minutes with T-Mobile, so T-Mobile loses money. And in order to identify Skype, you also need DPI. And then, of course, these different drivers, in a way, and different actors interested in DPI, that causes some problems. Economically, as I said, vertical integration, control of video on demand and so on by ISPs, that distorts the market for content providers. So it's not the open internet where anybody can set up a server anywhere in the world and offer any content and develop a business model on that. If ISPs now start differentiating between different content providers, there may be a problem. Same for telecommunications services, as I said. And you especially have a problem if you only have one ISP in a specific neighborhood. Then you actually need regulation in order to make sure that that ISP doesn't abuse this local monopoly. So the ISPs basically have to make a decision if they want to cut costs, which basically means cut traffic, or if they want to invest. That's basically the fundamental decision for many ISPs at the moment. Do they, because of oversubscription, because of more demanding applications and the rise of peer-to-peer traffic and so on, the ISPs have to decide if they want to do customer surveillance and use DPI and discriminate different applications and protocols, or if they, what they also could do, just invest in more bandwidth. So there's enough bandwidth for all applications at the same time. I'm not really sure yet how the customers deal with that. I think the consumer protection groups and related groups and institutions are only slowly picking up this whole debate around net neutrality and DPI and so on. So it may be, I think, at least in Germany, I'm not sure about other countries, it may be that people are just used to flat fees now. They don't want to pay per minute or per volume anymore. But I'm also not sure if they want to pay per application they use, or per website they visit, or per internet service they use. Yeah, and then there's also another thing that's interesting, has been mainly used in the UK so far, and for a short while in the US, where ISPs have started to monitor all the websites their customers are visiting. You know what Google is also doing with Google Analytics and so on, but not every website has Google Analytics built in. But my ISP, of course, can track every website I visit, so they know pretty well what I'm interested in and what not. And based on that knowledge, they have started to inject advertisements into the websites. And that is also based on deep packet inspection technology. And then, of course, a couple of consumer organizations and privacy organizations and so on have said this is not really cool. We don't want our ISPs to spy on us. And that, of course, leads to the whole debate about privacy. You could say this is a breach of telecommunications privacy. It's not really clear yet because there have been no Supreme Court decisions or something like that yet. If it actually is a case for data protection. I've talked to the Dutch data protection authorities, for example, when I was researching there, and they were pretty interested and pretty concerned about DPI, but they said, okay, if the ISPs just look into the traffic in real time and distinguish between different protocols and slow them down or route them somewhere else or whatever, but then right away forget about this afterwards, so they don't store any data about their customers, how is that a data protection issue? They weren't really sure how to deal with that. In general, it's sometimes a bit hard to explain, but if you try to compare it with street traffic, what DPI does is basically, if you compare it to the street, you drive down the street with your car, and then somebody in real time, while you pass some, I don't know, X-ray machine or whatever, naked scanner, car naked scanner, while you pass by that scanner, the scanner looks into your car and checks how many people are in there, what kind of goods do you transport, do you have a dog with you, for example, or whatever, are you smoking in your car or not, stuff like that. And then automatically do something with your car, with your engine, which you can't control, and slow you down, or put you on the slow lane or the fast lane, or tell you, oh, you now have to take a diversion, because we have to keep this lane free for, I don't know, people with bigger cars who pay more. And that's, of course, not really cool. I mean, people normally understand that this is not how street traffic works or should work. So I think there is a rising concern, also not just among experts, but also in the general internet community about DPI and things like that. I mean, the whole network neutrality debate is related to this. But of course, it's hard to say DPI is just evil. It has good purposes. It has been used against malware and spam and for security purposes for ages. So you can't just ban it. So we have to make sure how to use it. One thing for the ISPs, of course, is if they install this technology and potentially then have the knowledge, theoretically have the knowledge of all the content their customers are transporting, what happens to their liability? Störerhaftung in German. You know, this kind of stuff. If you suddenly end up in a position as an ISP to know what your customers are doing on the internet, you may have to legally do something about it if you, for example, have the capabilities now to find child pornography or other illegal content, for example. Yeah, I think I don't have to go into the filtering discussion in too much detail. So far, as I said, it's filtering and internet censorship has basically mainly been done with DNS and IP manipulations. But I see a danger if DPI is installed for other purposes, for bandwidth management, for advertising injections, or for whatever, that it then can also be used for censorship on top of that. You know, censorship is just another policy rule, but the machine is already there. Yeah, and then that's maybe interesting. That's what I tried to look at in the research project I did at TU Delft. It's not just that you have DPI, you put it somewhere in a network, and then stuff happens. But there's also variation. So what I found was variation across different use cases of DPI. I try to do a little typology here. Network security, for example, is not contested at all. People are just doing it. People who run networks just use DPI for security purposes, and that's fine. Nobody really cares. It's not politicized. So they can just do it because they do it in their own network, and that's fine. It becomes more interesting when more different actors interact. For example, if you have ISPs who operate in a market for end users, and some of them offer cheaper internet connectivity, but then manipulate your traffic with DPI. The customers who find out about this may say, okay, I don't like that, I go to another ISP. And actually there have been some initiatives, for example, in the Azoreus wiki, which is linked to one of the BitTorrent clients. People have actually collected a whole big list of ISPs and how they block or slow down or whatever manipulate BitTorrent traffic. So there is actually some kind of market transparency there, even crowdsourced. So then it becomes interesting when it's not just somebody who manages his own network, but when people compete on a market. And then, of course, it depends on market regulations, the market structure, and things like that. Then you have situations that are called negotiated agreement. That's basically when the ISPs are not really actually in favor of using DPI for a specific purpose, but other actors want them to do that. That's mainly the cases of copyright filtering and, of course, censoring illegal content like child porn. ISPs don't have a business interest in doing that, but other actors like the copyright industry or the governments come to them and say, but you really must do this. If you don't, we will enact a law, so you have to do it anyway, or you morally should do it, otherwise we do a public campaign against you, or whatever. Then what you normally find is some kind of negotiated agreement. The ISPs have a pretty strong position here because they are the ones who have to be convinced to do this. And then it depends on what kind of tools the other actors have. If they have legal means of forcing the ISPs, if they just have publicity means or things like that. There's a couple of different interesting cases on that, on copyright filtering cases in Ireland and Belgium, for example, and of course on child porn filtering and so on. And then you have the classical hierarchical decision making. The government tells ISPs, you have to do this, full stop. That was, for example, the case after 9/11 when the National Security Agency went to the big internet providers and just tapped all their lines, even domestic lines in the US. How many time is left? How much time? Okay. So you have variation across use cases, as I said. Different use cases of DPI have different strategic constellations among the actors and therefore also different outcomes. Sometimes in these cases DPI is not done because ISPs can just stop filtering censorship, for example. And then you also find variation across countries for the same use cases. I've just picked one example here, bandwidth management. That was basically BitTorrent blocking or BitTorrent throttling, which has been done by a couple of ISPs in the US and Canada, two countries which are neighbors and really pretty close. But the strategic and also institutional and legal situation was different. So in a way the outcome also differed. In Canada you have a pretty active privacy movement, a lot of professional privacy groups, and you have a privacy law and a privacy commissioner, like the commissioners here in Europe, with legal powers and so on, with actual oversight over the private sector. So when people found out that some of the ISPs were blocking BitTorrent traffic, the privacy groups became involved and triggered some activities with the Privacy Commissioner. So the whole debate around DPI and net neutrality in Canada has been framed as a privacy problem. And in the US, the situation was different. There was a strong net neutrality movement. There are, of course, also some pretty active privacy groups, but the United States don't have a privacy law for the private sector, only for very few specific sectors like the health sector, but not for internet and telecommunications. So in the US, this whole thing was not a privacy issue, but it was a net neutrality issue. And you had the Federal Communications Commission, which has oversight over the internet, though I just read that that's contested now. Some US court has said recently, a few days ago or something, that the FCC doesn't have oversight over the internet anymore, but I think they will sort that out. So in the end, the FCC in this case defined internet freedoms and things like that, this kind of net neutrality declaration by the FCC, but they didn't mention privacy at all. And that's not really a big issue in the US debates around DPI. Whereas the Canadian Privacy Commissioner, has set up a whole website and collected a number of essays from experts and other people on DPI and really has framed this as a privacy thing. So my preliminary conclusions in that project in Delft were you have variation across use cases, and they are more or less explained by the policy implications of the specific DPI usage, which basically boils down to if the ISP has an interest in using DPI for a specific purpose, they normally can just go ahead and do it, and then if other actors don't want them to do this, the conflict starts and there may be some kind of compromise in the end or something like that. If others want the ISP to use DPI to filter, to block, to whatever, then ISPs have a pretty strong veto position here. And they normally can only be forced if there are legal threats or something like that. Okay, I'm finishing anyway, so we can have feedback on that. And variation across countries, of course, for the same DPI use cases is based mainly on the institutional settings and on the legal background. And of course on the actor constellation. If you have a privacy movement in a country, or if you have a net neutrality movement, or if you have organized consumer groups who are interested in DPI, things like that. Okay, that's my part, and now there was already the first intervention. I think we can use this microphone here.
Yeah, sorry for being so noisy. This was not what I wanted. But I think that's not true, because you don't have the situation nowhere in the Western world that the ISP has a veto position against the government. If the government wants you to monitor by deep packet inspection or whatever, they'll force you. And it is absolutely untrue that is something which has to do with negotiation. We have had the situation in Germany, that's true, that companies like Vodafone started to negotiate in a specific type of ruling, that whole Zensursula thing with the government. But that's not the usual situation. The usual situation is that the government in Saudi Arabia says to the local or international ISP that they want them to do that, and that. So sometimes they do it for themselves by a government agency like the NSA in the USA, or they force the ISP that he has to fulfill some kind of rules. So I can't see, and the second thing is, which I have the whole problem with, I have this whole day with the net neutrality discussion, is that I think we should more be cautious. We combine the American discussion about net neutrality, which has something to do with the economics of the net in the US, which is totally different of the whole system we have in Germany, and we combine it with our fight for the freedom of expression. And I think it's dangerous that we do that. We shouldn't do that because the American situation doesn't really fit to the American discussion doesn't really fit to the German and the European. And I think we should be more exact about it, because if we don't do that, then we lose the second fight.
If I can just quickly react, I was trying to say exactly that we can compare American and Canadian and German and whatever debates on DPI and net neutrality in order to understand the differences. That was my point, more or less. I don't think we should just ignore them. On the first point, of course, if the government enacts a law which says ISPs have to do this and that, filtering, censorship, whatever, then they just have to do it. But it's not always that easy. In a couple of countries in Germany, the police, for example, or other institutions like the Internet Watch Foundation are just providing these filtering lists, and then the ISPs are not exactly legally required to use them, but it's like, okay, now we have this list and you will use them, and it's a good hint for, at least that's what I heard from Denmark and other countries, that's how it works there. So it's exactly not really clear who is liable in the end for if something is overblocked. If it's the police who provides these lists in Denmark, or is it the ISPs who use it. And then, of course, in cases like copyright filtering, there were some cases in Belgium, in Ireland, and so on, where the content industry went to court and tried to force the ISPs to block, to use DPI for detecting copyrighted MP3s, for example. And then, okay, you could say court decisions are not negotiated, but actually in the Belgian case, the ISP had a pretty strong position because it was able to convince the court that this technology was not working in the way the content industry was presenting it, and so on. So I think it's not always just government hierarchical decision and that's implemented and that's it.
I have a question. You said that the packet inspection technology is not 100% bad, and there are good issues too. But I think, isn't it the only well-working infrastructure, censorship infrastructure that we can imagine today? And so it is I don't know the English word, the Büchse of the Pandora, die wir da, and isn't it that we strongly have to try to make a law that no one can ever use this technology, perhaps for privacy issues like the Briefgeheimnis, something.
Well, the thing is that DPI actually is very useful in certain areas. One is everything that's got to do with quality of service. And that's a hot topic because there are new kinds of services based on IP that need real-time transmission, like telephony, TV, etc., etc. So people need that. You can't say we completely drop the technology because that means you also kick out a lot of the quality of service stuff. And the other issue where that's very important technology is in protection against denial of service attacks. If you have a distributed denial of service attack, tens of gigabits of traffic coming in from everywhere, then DPI is your only chance to keep a working network. So it's a complete illusion to that you could be able to prevent ISPs from deploying that technology. But the technology is neutral there. DPI is not the same as violating net neutrality or censorship. It's a tool that can be used for both of that, but it can also be used and it must be used, and you need to have that for a working network for traffic management purposes, which can also be policy neutral.
You focused very much on bandwidth and content filtering stuff, and mentioned advertising only. mention it only, but there has been some problems or criticism in Britain with the form thing, which the system which provides advertising based on the things users look at. So and basically this was also a privacy issue. Is it possible to do a content advertising with DPI without and also protect the privacy of the user?
Yeah, the case of form was interesting because that's what I also looked at in my research, where I compared the American debate on ad injection with the UK debate. And in the US, when people found out that their ISPs look into their website traffic and inject advertisements based on that, people were furious. And I think Attorney General of Michigan sent a letter to, I forgot the name of the ISP, Charter, I think, Charter Communications, sent a letter to them and threatened legal activities. And a couple of congressmen became pretty active, and there was a public outcry. And after that, the US-based companies who did ad injection basically went out of business. The market was dead. In the UK, where there was actually strong resistance from the what's it called, FIPA, Foundation for Information Policy Research, I think. They did some really good analysis of the form system, legal and technical, and a big campaign by privacy activists and so on. But the British Information Commissioner, who is also the Data Protection Commissioner, he just said, oh yeah, maybe it wasn't so nice, next time you do it, you should do it based on an opt-in, so the customers can opt in before they are surveyed. But this was only a field test, so you don't even have to pay any damages or something, which basically meant in the US, ad injection was dead, and in the UK it was still live and kicking. But then, interestingly, the European Union jumped on that. The then Information Commissioner Viviane Reding, who's now the Justice Commissioner, started what's the English term? Vertragsverletzungsverfahren. So she basically threatened to take the UK to the European Court of Justice because they don't really implement the European Privacy Directive. And now actually Form has stopped its activities in the UK. I think they're still active in Japan and Korea or something, but that was an interesting case of new business models, and ISPs now can make some extra money. You know, they're always complaining that Google makes all the money and they don't. So they were able to make some extra money, and some of them actually did it, but then based on public protests and so on, and some legal threats, this specific use case of DPI, at least in the Western world, is dead now.
If you make it really quick, because
yeah, real quick. It's just a technical question. Basically, you can probably answer. As far as I understood, this is mostly working on header data of the information that is transmitted, and not actually looking into the actual data. I mean, like if you transfer an MP3 file, for example, you get the information about the file type and what it is, or is it actually comparing the bit structure of the file against a bit pattern that has been defined?
You can go as far as looking for specific bit patterns in the data, in the traffic, and analyzing protocols and looking for certain features in certain protocols be used, certain data transferred. It's all possible.
Okay.
Okay, then thanks for your attention, and yeah, bye.
Also das meine ich, also die Leute, die am Ende irgendwelche illegalen Content wie eine Pornografie oder sowas dann tatsächlich veröffentlichen wollen, die können das ja wahrscheinlich dann relativ einfach umgehen. Also das kann man, nicht eine Barriere, es wird auch noch andere Sachen der Header-Daten eher als die